Hey everyone, this is Genesis here, and I'm coming at you today with another video of Dissension and ARMA coding. So today is going to be a little bit different. It's a bit more script heavy and a little more theory crafting, and I also have a little bit different of a setup. So it's going to be a little trying to figure out things working here. So I'm just going to jump right into it and say, well, I was working on Dissension, and I realized I needed a way to compare and find which two objects are closest together from two different arrays. And I need this function to be smart enough to know if it's a marker or if it's just another position or an array, or if it's an object or if it's a location. So I need to know all these things about it. And I needed to take array 1 and check on array 2 and see for each individual thing in array 1, I needed to check in array 2 the distance of each other. So for like this little guy here, I needed to check the distance of this guy and this guy and this guy and this guy. So you get the point. It's very complicated. Not really, but I'd say it's more intensive is what the right word to use there. So before I go explaining why I needed that for Dissension, I will show you how I got it to work and what function I'm using now, and explain a little bit of its overhead and its cost, and maybe some purposes for it. So I came up with a function like this: array compare. And there might be, I'm sure there's a better way to do this. This is the shortest way that I could do it, and this is what I love is making your own things. I think I'd love enjoying making my own functions and creating solutions to my own problems. So I came up with this, and I'll quickly go through how it works, and through that you might understand why I consider it a heavy function to run. And by heavy I mean a lot of overhead. It takes probably quite a bit to run compared to other things out there. And I will show you that later as well. So all it does is you give it to the two arrays I was talking about, array 1 and array 2. And then you tell it how you want it to sort it. Do you want the shortest distance to be on top or the longest distance to be on top? If you put true, the shortest will be on top. If you put false, the furthest will be on top. So you just give it that information, and then it does the rest for you. It defines the empty array, and then it looks at for everything in array 1. That's what this whole chunk right here is. Everything in array 1 it looks at, and it goes, okay, let's remember what the thing is in array 1. So say it's okay, so it goes through each one step by step. So say we're looking at the first object in array 1. Cool, we're looking at, let's say like Bob 1. Cool, and it goes, okay, let's remember Bob 1 as underscore O. So this is like Bob 1. Okay, so once we have Bob, we're going to redefine him as underscore O. We're going to see if he's an object. Then we need to get pause ASL. I'm using ASL because I believe, it's one of the faster ways to get the positions engine-wise. Okay, so if he's not an object, then maybe he's a marker or a string. So if it's a string, then we need to get marker pause. And if he's not either of these, then he must just be a coordinate or location. So let's just go ahead and just have pause be Bob. We don't need to get the position of anything, just let it be himself. Okay, so once we get the position of O, then we need to go through every single thing in array 2 and compare O, the single O, to every single thing in array 2. So we need to do the same process. We find out if it's an object, string, or an array and grab its position. Then we do the distance comparison. So we take the position that we got from O up here, and we find the distance between pos 2, which is the object we're currently looking at in array 2, and then we put it into an array, like so. We put the distance in, we put the object, and then we put the object from array 2, and here's the object in array 1. The object from array 1 will always be this select 1. The object in array 2 will always be this select 2. I just felt like it made more sense, to my mind that way. So that's it. And the reason why that is so expensive and has a lot of overhead is because for every unit, everything you have in array 1, it's checking every single thing in array 2. That's multiplicative. which means that if I'm checking 21, I set up a test, I have 21 each. That means it's 21 times 21. That is 441 entries, roughly, I believe. I think that's it. So that's a lot. That's a huge array. Then it gets this giant array, and then on top of that, it sorts it. It sorts it in whatever order you tell it to, and then it finally spits it out. Like so. It feels like a lot. So let's see it in action. So let me go ahead and compile it here. And I already have this thing written up. You can see I named all the objects, all the infantry on the map, Bob. And there's 21 of them. It starts for Bob here and goes to Bob 20. So it's a little confusing. There's actually 21 of them if you count Bob here, the original Bob. And here's RAR, which are markers. And then I want to sort of shortest on top. And then what I want to do, and I call it here. And then here I just want to copy it in my clipboard. And I just executed it right there. So let's see what this looks like. Wow. Look at that. That's a lot of entries. Let's see if it works right. I'm lying to you. I already know that it works because I don't want to waste time trying to debug it. So you can see if I just separate a few of these, generally that they are, yep, that's being sorted correctly. And you have the shortest distance here is between Bob 11 and RAR 17 at 105 meters. And the furthest is going to be looked all the way down here. It looks like Bob 13 and, oh, I'm sorry, actually down here. Bob 13 and RAR 3 at 3,834 meters. So, there we go. You can kind of see how that works. That actually makes a cool pattern right here. It's kind of cool looking. So, see, it's a lot. So, imagine if you had 50 times 50. Oh boy, it gets large very quickly. You can see why that's, you know, it could be a little scary. So, and I wonder if we can actually simulate the difference here in a second. So, let's talk about what I keep meaning when it's heavy, or when it takes a long time. I did a couple tests to see how long it took to run with 21. And on average, I did this little test here, and the biggest thing you want to look at is right here. The final result after running it 1,000 times is that it took an average of 3.22. We'll round it up to 3.23 milliseconds of runtime for that to finish. Okay. And if you look at, you know, that may sound like a very short time, but if you, and this is me, like, this is actually, all these right here are me trying to figure out which the fastest way to get it. And I actually got it down from 3.5 down to 3.2, which helps a little. But you can see 3.2 compared to some of these other functions I've tested, like 0.065, oh, 0.066, 0.04, 0.02, 0.004. Like, that's a pretty heavy one. And let's go ahead, just for shits and giggles, I'm curious now, what happens if I do put 50 things in here and how that will work. So what we're going to do is I'm going to come back into here and I'm going to hold this up, and I want to grab this whole thing here. Let's see if I can do this. Okay. And we're going to put this in here. And what I'm going to do instead of adding more characters, I'm just going to actually repeat this whole array to have it just go through them again, and that should have the same result in the end. So now there's 40 in there. Let's do 40 and 40. Let's see how bad 40 and 40 is. Let's see, we'll double it. Actually, this will be 42. Let's see how bad 42 and 42 becomes. Okay. So then what we want to do is replace this. Let's see. This with this here. And what we're going to do is we're going to go ahead and run this again. And let's see how it goes. Once that count in the bottom left gets to 1,000, then that means that it'll done. We'll have our results. And the reason why I'm doing this way is because while that's going, the add code performance, you can tell it how many you want it to run right here at 10,000. But since I always do this in a multiplayer environment, and I never go from the single play editor, it only runs once, and I want to compare the averages of 1,000 runs in multiplayer to be able to do that too. So I just created my own little function that will count for me, and it does it's going to run 1,001 times, and we'll see. So there we go. Look at that. Look at the increase. So now 15 milliseconds on average. That made it worse, and it's probably even worse because I'm using markers as well, so it has to do more calculations. That's a hefty ass function. Like, that is huge. So let's do one more test. Or now I'm curious if I change this back to, so 15 seconds, right? I'm gonna copy this. Let's go back to using mark. So let's do 2 objects. Let's see. So right now that one's at 15 seconds. Let's go ahead and do the same thing, but instead of using markers, we're going to use object and object. Because I'm actually just curious now. Let's do it again. So you can see why that's a long time to run, and this is definitely not a function you want to use very often. And if there's a better way to do it, I'm trying to think if there's a better way to find distance between every object in an array and find which one's closest to each other. Maybe there is, so if anyone knows, please let me know. But I made a post in the forums. It was, people helped me optimize it, but I had less than helpful results. Okay, so using objects, using only objects, you get a 12.98. So you can see there's a difference in between using objects and markers and mixing it. For sure makes it more complicated. That's a lot of runtime. That is a massive amount of runtime. So in Dissension, fortunately what I'm using it for, it's going to be probably max like 10 territories is going to be checking for, and the trick is going to be like, let's create a solution, maybe like a situation that would be more realistic in Dissension. So Dissension is going to be looking at, okay, we have 12 territories that we want to check. So I'm going to get rid of a lot of these bobs here. We'll say these are the territories we want to check. And we'll say, yeah, there's 40 troops, 41 troops active, or 42, I think this is now, active for OP4. We want to see which OP4 unit marks. Mark's going to be OP4. Which OP4 unit is closer to our territory. So that's what I want to use it for. And we'll have it run again with that situation. And we'll go ahead, let's see, realistic situation is going to be, we'll see what that turns out to be. So the reason why I'm stressing so much for performance, and look at that, that's actually much better. So the less you have in array 1, the better. So look at that. Which will put that less in array 1. And I think less in both is helpful. But look at that, 3.95. It cuts it down back to 3.95. So the more you have in array 1, the more hurtful the performance is, which is good to know. So that's, got to be kind of smart when you're using it. So why, and I've been talking about this, why does this matter? Because, well, and I already implemented it into the mission here. This matters because if they're using a function that gets executed a lot, and a lot, and a lot, and a lot, it's going to slow down the mission. It needs to be as quick as possible. If you have any function that gets ran over and over and over again, you need to do it quickly. So what I'm thinking I'm going to do for this is, instead of having it execute as a local variable, I think I'm going to have it run by itself like every, we'll say, minute. Maybe we can even do it every 2 minutes. We'll have it spawn, and it'll redefine. It doesn't need to be a call. It can just be a, maybe it should just be a call. Let's figure that out. But every 2 minutes, I might just have it call and redefine every 2 minutes or so, or maybe we'll start with it maybe every minute and see how that goes, because we don't need to have it update all the time. It can be a little inaccurate, so it doesn't need to be updated. So I think that will offset the cost and make it not as noticeable, but we'll have to see. So we are going to go ahead and do that. And so what I'm doing now in Dissension to get now to probably what you're here for is I created the missions. The missions are very basically done. They're in there. I got some basic ones for each commander that does. They do bomb defusal, hostage rescue, ambush, destroy, and escort mission and defense mission. It's just something to vary it up. Now, when there's no enemy nearby, these missions are very I should say, they're very basic. You just fight independent. The enemy's too far away. But what I needed to do here, why I needed that was I need to be able to detect when there's someone too close or really close, and I need to have them do these special missions, which I'm going to add to the mission list here. So that's the whole point for that. So what I'm thinking of doing, if I ran the brain of the commanders, is I want them to, maybe I might just include this in the create mission here. No, I'm not. This will be separate. This is going to be completely separate. I'm trying to figure out how to do it. So you can see here, I'm trying to figure out how to design it best. I have the distance of the enemy taken into account, the size of the enemy force, what kind of vehicles, and the appropriate response. So first thing I need to do is get the distance of the enemy, which is that whole function is for. And I need to do each grid that we own and not just from the commander, because that can create a lot of issues. So let's go ahead and I'm just trying to think now. You know what? I wonder if... No, that won't work. Okay, so I was trying to think of a way to optimize this function, but now I just thought it through, it won't work. So what we need to do is find the distance of the enemy, and then if they're close enough here, then we need to do a threat assess, which is going to be this function here, which I'll be doing in a future video, of creating how to assess for a threat of the enemy and respond accordingly. And so what we need to do right here is where I need to do the check for distance. Right now I have a simple, if the enemy is within 2,000 meters of the commander, then we need to respond. But that doesn't work, because if the commander captures a territory and moves, and then there's territory that's 3,000, 4,000 meters away, they won't respond properly to protect this territory. And I can't have this be like 10,000, because they'll always be sending troops to do these special missions if they're like 10,000 now. It doesn't make sense. So that's what the whole function's for. So what are we going to do? Well, using that function, what we're going to do is come back down here to the basic variables. Let's spawn a loop that will constantly define the distance of the enemy's two territories. And I'm just going to put a spawn here. What I want to do is while true do, and this is going to change later to make it more flexible and optimized. And I'm going to see how much time we have left, guys. Oh, we got 11 minutes. I also added a sound, so I'll know when to stop. Sometimes I don't. Take a look. So what I want to do here is, as soon as the commander spawn, I want them. We'll have it run. Let's see. We'll have it run instantly. We'll have it run like maybe 5 seconds in, and then we'll have it check every minute, like something like that. Don't do this. Since I learned on my own, and I really didn't have anyone helping me besides the forums or anything, I learned a lot of bad habits, and one of the habits I learned was don't really care about making it optimized at first. I don't really care about making it look pretty at first. I want to see if I can make it work, and then I'll go back and fix it later, because I really enjoy that process. Okay, so now we want to run this command called dis_c. So we need to put a call dis for dissension a distance c, and what I need to provide to it is the array1, and array 2. And array 1 should be our territories that we have, and array 2 should be the enemy, and the order will be true. So we do know one of these is going to be true, right? And then now we need to run a calculation in here of all of the territories we own, which I believe we already have. Where did I put that? Did I put that in thread assess? Do I have anything in thread assess? Oh man, I forgot where I put that. Here we are. So this right here is the summed own of everything we own. And actually, I might make this. Yeah, so what we'll do is we'll take this. Interesting. Okay. So I'm just, there's so much going on here. I'm just trying to remember all I'm doing. So what I'm going to do is actually create this in a notepad file here, because I hate writing into an FSM directly. Just hurts my eyeballs. Why is this an odd shape? I just realized that's an odd shape. So, get back to your box. Get back to the box. So we're going to create this in here. So what I want to do is create a loop that is constantly checking. Oh my gosh, this is not even formatted, or not even using my SQF stuff. That's fine. So it's going to sleep 5 seconds. It's going to pull everything that Blue4 has and put it all into the M defense array. And that's going to be array 1. And then now we need to pull all the enemies. And I think did I have a function for finding enemies already? It's closest enemy. And here's going to be a great test for optimization. So, and we're going to learn this together because this is something I read and I don't remember how they did it. But I'm going to add in some op4 units over here. I'm just going to spam a few over here. Okay. I'll go ahead and play this. So what I'm thinking now, what I want to do to find all the enemies is see this function right here. Let's just take this, and if I come into here, this is one thing I use. Target side is going to be, we're just going to get rid of this. Oh, wait a second. Give me 1 second to finish that thought. What did I do here? Oh, whoops, I messed that up. We need target side. The unit side is going to be west. So usually I have count all units, which is quicker. What I need to do is actually get rid of this and just have this return true. So what I do here for this to find all the enemy units, like let's go ahead and launch this up. For big arrays, this is going to matter a lot. So count all units is one way to do it, but it takes every unit and it figures out which one is on the enemy side, or this command right here figures out which one is on the side of the enemy, and then it pushes back the array. And we can do hint, format. We can do let's do array 1. You can see it very quickly puts an array of enemies, right? Awesome. Look at that. Look at that. Look, it's so awesome. But it's not the most optimized way to do it. The most optimized way to do it is something, I have to even remember, it was like, let's take a look together. Instead of doing all units, things like entities, and you do minus side west or something, or, because you want to minimize the amount of iterations you get. So maybe I can do all units, and we'll test this too. So all units minus, how do you do that? See, this is stuff I don't remember. So let's go ahead and take a look at. I don't think it'll be in here, but let's take a look. Mm-mm. Nope. Nope, 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 nope. We're going to... Gosh, now I can't remember that, and I feel a little silly even bringing that up. Let's go ahead and take a look at Bohemian Farms here. I made a post in a thread to bookmark it, and it's right in there, so I can show. Wow, these notifications! I just checked it like not too long ago. I thought, let me see. Oh my gosh. Where are, can I see the ones that I've posted in? Activity. We're gonna get there, guys. Here we go. I think it actually was in this thread right here. Okay, beautiful. Ah, here we go. Ah, that's it. See this setup right here? Bam. For each count. Let's see if I can adjust it. So what this does, thank you for waiting. Let me check the okay. What this does is that it pulls all the units only that have a certain side. Now the reason for that is that it reduces the amount of times this has to iterate through. So if we just keep the old way of doing it, and we do this. Let's compare the speed now. We're going to add a bunch more units to a more realistic manner, and we're going to run both here. So actually we'll just enable Zeus here. I'll finish this up. So what we can do then, so maybe speed this up, is instead of doing this whole command here, I mean side is enemy. Can I change this to, so side X, we can take this command right here. Put it in here, change this to side underscore X. And then get rid of that. Get rid of that. Get rid of this. That's less code that it has to execute. Let's go ahead and add a bunch of op4s. A more realistic manner what Dissension wouldn't be like. Instead of like 10 units running around, might be one side might have something like maybe 50 to 60. And I'm just gonna even just go crazy with it to make a point, because I'm also curious about this. So I've been trying to really focus on a lot of optimization. Okay, here's a lot of units. I don't think Dissension will never have that many running around at once, but let's go ahead and run this and see what happens. See if we get an error. There we go. It put it together. It looks like that's all op4. So let's see. Oh, I got some weird stuff going on here. Let's do some speed tests to see how long these actually are. So we're going to go ahead and, or how long these take to run. Compare this way and this way together here. So let's go ahead and pull up speed test. I'm going to just copy this entire thing here. We're going to be comparing all units, command usage for most efficiency. And what we're going to do is get rid of this call right here. And we're just going to go into, put that here. We're going to try the old way first. See how long that takes. This looks really messy, and that's okay. All we need is the result. And let's have it run. The hint is actually going to slow this down quite significantly. And I probably need to not do it with the hint, so I just realized that. So let's go ahead and we're going to get rid of that hint. and then redo it. That should speed it up. The hints is jet. Oh, guys, I'm out of additional pylons. That means I'm gonna have to get going. We're gonna do this test. I gotta build some more pylons. I gotta play some StarCraft. We're gonna go ahead and do this last test, and we're gonna call it good. Yeah. So where I'm at in Dissension is creating the missions. I'm creating the AI now. Going to be able to respond to external threats much better, which I'm very excited about. Okay, you can see that took around 4 milliseconds to run. Alright, so now let's go ahead and test this way. And we're going to go ahead and go to speed test. We're going to replace all this in here with that. Get rid of the hand, of course. Let's see if this runs any faster. Hope is yes. Hope is yes that it runs much faster. I won't move around to throw it off or anything. So you can see it's going through, it's iterating it, iterating it, iterating it, iterating it, and bam. The result. I would argue that is definitely much faster. A little too close to tell. And also might be the tough thing about it is I'm doing this call is side is enemy. So I think it's doing a check to see if that is actually the side. The enemy is that side. But this is definitely, I say that's not just chance that it was 0.3 quicker. So that's still faster. You should be doing this way. That's beautiful. So yeah, what I'm going to do is finish this up. And I'm going to move on to creating this loop, so constantly be defining who to check. I'm going to be making this, dumping this to a global variable, and then I'm going to be moving on to doing the threat assessment and how the AI will determine what the biggest threats are and how to deal with those. Alright, so I will see you guys next time. Thank you so much.